Good day, students. You are welcome to another round of Screencast. This is for week 11, the final week for this module. We shall be looking at cubic graphs and tangency, how to draw cubic graphs and how to determine the equation tangential to any function. Let's start with tutorial 1, where we're looking at sketching cubic graphs. This is a typical question. For example 1, we're going to sketch the following cubic functions by determining first the shape of the graph, the x and y intercepts, and the coordinates of the turning points. And thereafter we can then draw the graph. Now, remember in the lectures I said to determine the shape of any cubic graph, if you're given any function, you look at the sign of the coefficient of x cubed. If the sign is positive, it's going to give you an increasing graph just like that. That is for a positive sign of the coefficient of x cubed. But if the sign is negative for the coefficient of x cubed, it becomes a downward sloping and then reaches the minimum and rises and drops. That should be the shape. Now let's look at this example. Now, the second thing to do is to find the x and y intercepts of this function. And so we start by applying the rule that to find the x-intercept we make y to be 0, and to find the x-intercept, to find the y-intercept we make x to be 0. So let's start first by finding the y-intercept. And so we make x to be 0. So in this case, my function here, I substitute for x, that's 0, that's it there. And so I have 12 by the time I simplify that. So it means my y-intercept is 12. Let's find the x-intercept. To find the x-intercept also, you make your y to be 0. So in this case, if I make y to be 0, I will have the whole of that function above there. Let's go there. The whole of this function will be equal to 0. And if I have to make the whole of this function here, if I should copy it out and put it there and equate it to 0, I'm going to have a cubic function. And the way to factorize a cubic function to find the x roots will be to first of all find, by the method of the trial and error, find the values of x that will make this to be equal to 0. And that means you've got to try values of x. I would advise that you start with from -3 to -2 to -1 and then to go to 0, 1, 2, 3. From all these values, you are likely to have the first value. So by trial and error, we try values from the negative to the positive. Without wasting much time, I know that 1 is the value that will make this equation to be 0. So I will just use 1. But you've got to try all the values between -3 minimum to about +3. You are likely to have one value. The value that is going to give me a 0 is 1. So I put 1 there for x, and then I have that. By the time I do that, you will see that my value will give me 0. So it tells me that x equals to 1 is a value, and x minus 1 is a factor. That means if I put 1 to that side, it becomes a -1. That becomes a factor. Now, that's just one factor. We need 2 more factors because it's a cubic function. It has to be 3 factors of x. And now to find the remaining factors of x, I will use the k method to determine these. The other 2 methods you can use is the long division method, and also you can use the syntactic division. But for this exercise, we shall be using only the k method, which I think is very reasonable and short. So how do we use the k method? This is what we do. We take the first factor, which is that, and then we multiply it by the second factor that we are looking for. And how do we do that? First, this is what you do. You take your x cubed, which is the first factor, you divide it by x there, that gives you x squared. You take the last factor, which is +12, you divide by -1, it gives you -12. You put it at the back. And then you have the middle part open. and that middle part, which is your middle factor, will use kx. Why are we using kx? Because we know the middle term should be a power of 1 for x, but we don't know the coefficient, so we use k. That's where the word or the name comes from, the k method. So now what we do next is we try to open up this bracket. That's the ideal thing to do. You open up this bracket and find out or bring out all the factors of x squared. Now if you don't want to do that, we could as well just find the factors of x squared here, which I'm going to teach you now. This is how to quickly determine the factors of x squared. The first factor of x squared is your minus 1 times x squared. That's going to give you negative x squared. That's why I bring it out there. That's the first factor of that. Now, there's a little bit of error there. That should be x squared, not x. So I'm going to erase that and put x squared there. Now, how am I sure it's x squared? That's the second factor. It's x times kx. That gives me kx squared. Now, at this point now, we can simplify. What do I mean by simplification? We can take this minus x squared to that side because they are like terms. So if you do that, it becomes a positive on that side. If I take that to that side, it becomes a positive x squared. It will be minus 5x squared plus x squared. And that will give me minus 4x squared. So I'll be having kx squared. I'll be having kx squared equals negative 4x squared. Just like that. Let's do it well. Equals negative 4x squared. Just put it rightly. Minus 4x squared. Now, if you try to solve for x there, you will be having k equals to minus 4 because the x squared will cancel out, and so you have k equals to minus 4. Now, you substitute back your k equals to minus 4 there, and so it becomes x squared minus 4x squared minus 12. Now, this is your second factor you're looking for, but because it's a quadratic factor or expression, we need to factorize. So if I factorize that, the factors of minus 12 as a product to give me negative 4. When I add, the factors are 2 and minus 6. 2 times minus 6 will give you minus 12. 2 plus minus 6 will give you minus 4. So those are the factors. So I have the remaining 2 factors I'm looking for. So I can write these ones there with the other one I have before, which was, if you remember, is x minus 1. That's the first factor. So it is x minus 1, x plus 2, x minus 6. It doesn't really matter how you arrange it, but those are the 3 factors. So it means your roots for x are minus 2. If you solve for x there, it will be 1, and then it should be what? 6. Those are the x intercepts. Now, after getting your x and y intercepts, the next step is to find the turning points. Determine the turning points. And how do you determine the turning points? We differentiate the cubic function. So if I want to differentiate that, it becomes 3x squared. Differentiate that, becomes minus 10x. Differentiate that, it gives you minus 8. After differentiating, we need to solve for x to find the x turning points. So if I factorize that, the factors of 24, which is 3 times minus 8, should give me positive 6. Add this if I factorize out. If you are not comfortable with factorizing, you can use your formula method to solve for x. So if I do that, the x values will be x equals to minus 2 over 3 if I solve for x there, and the other value of x will be x equals to 4. These are the turning points for x values. You need to find the turning points for y value. So if you go down, what I need to do to find my y turning points is for me to substitute minus 2 over 3 in the original function, the original equation. And the original equation is x cubed minus 5x squared minus 8x plus 12. So I just substitute for minus 2 over 3 as x. That's it there, and that's it there. You open the brackets using your calculator. You're going to have 400 over 27. That is your y turning point, the first y turning point. Now you need to write that in a coordinate form. What do I mean? It means your x and y must be together. So it is your x value there, and that's the relative y value for the turning point. Now the second turning point for y would be for us to use the second value of x there, And so I use x as 4 in my original function. And if I do that by substituting for x, I'm going to find out that my y will be minus 36. So writing that in a coordinate form, it will be 4 minus 36. That's it there. That's your second coordinate of your turning point. Now, we've done all the necessary calculations. The next step is for us to now sketch the graph. In sketching your graph, it is advisable that you get to know all the turning points. And so what I'm going to be doing now here is I first of all write out, let me move this rightly, I write out all my turning points as well as my coordinates. All my turning points as well as my coordinates. Now, these are the x values of my my intercept. So I have minus 2, 1, and 6. And I have the x-intercept on the x-intercepts. This is the y-intercept, which is there as 12. And then I have the turning points. The first turning point is that one here, 4 and minus 36. So I will assume somewhere there is 4. Let's just try and put it correctly. Okay. Somewhere there is your 4. So your 4 there, when you find it with intercept, it's intercepting with 4 and minus 36. So I will assume that that is the turning point. Maybe I need to move this up just to make it more reasonable. Let's move it somewhere there. And then we write our minus 36 somewhere there. And so we see that the turning point is 4 and minus 36. So you put a star there. The second turning point is at minus 2 over 3 and 400 over 27. That should be about 14.8. So it should be around somewhere there. And then, oh, sorry. So it means that is the second turning point, which means from this point there, it meets up there. And then all I need to do is to now join those points. Now I know I'm going to be moving up because I know the shape initially. So you just move up like that, move up like that. You stop at that point as the turning point. You move down, and then you meet it at that point of 12, which is your y-intercept. You move down to 1, which is one of your x-intercept. From 1, you move down to your next turning point, which is 4 and minus 36. After that, you move up to 6, which is one of your intercept of x, and then you can extend it as long as you want. That is the shape of how to draw a cubic graph. Let's see example 2. In example 2 also we have a function of x cubed plus 3x squared minus 9x minus 27. Now here also the first thing to do, as we have been told, is to find your x and y intercepts. Okay, so if I want to find my y-intercept here, if I put x to be 0, my y-intercept will be minus 27. And then the next step is to find my x-intercepts by making y to be 0. And that's what I'm doing here. The value that will make this one to be 0 is 3. I've already done that for you. 3 is the value of x that will make that to be 0. So it means my first x-intercept will be x equals to 3. Or you can say x minus 3 is a factor. After that, using the k method, as we have been taught before, if I divide x by x cubed or x cubed by x, I'm going to have x squared plus kx, which is my numerator term. I divide minus 27 by minus 3, I have positive 9. So now, using the k method, take out here the powers of x squared. The first power of x squared is minus 3 times x, which is minus 3x squared. The second factor of x squared is x times kx, which is kx squared. Sorry for that. That should be kx squared. So I'm going to have to copy that and put it there. And then from there, transfer that to that side. It becomes 6x squared. If you solve for k, k will be 6. And then you put your 6 in replacement of your k there. It gives you a quadratic function. To factorize this using the method of factorization, you have x plus 3 to give you that. And then you have all your three intercepts. X equals to 3, x equals to minus 3, or x equals to minus 3. Now, when you have two roots repeated, it's telling you that that graph is a double root graph, as we are going to be seeing later. Now, let's now find a turning point. So here is the turning point. And I've told you to find a turning point, you differentiate that function, which is going to give you that. And then after that, you try to solve for x. Now, I decided to divide this by 3 because I can see that 3 is a common factor. And that gives me that. So I can factorize this one. The factors of minus 3 to give me a positive 2 when I add is 3 and minus 1. And so that gives me the remaining the two turning points of x values. Now, after getting your turning points of x values, you can find your y turning point by substituting these two in there. Sorry, in the original function. Sorry. So you're going to be substituting minus 3 in there, and that's what you're going to have. If you do that, you're going to have minus 36. If you substitute 1 in there, you're going to have the next value there down, which is minus 32. So that gives us the first turning point, and this one gives us the second turning point. And after doing that, you finish your calculation. You now do your sketch, last sketch there. Those are the two turning points, and that's the value, the various x-intercepts and your y-intercepts. So if I have to draw that, I know, now you need to be careful here. You know obviously it's going to be an increasing function because the coefficient of the sign of your coefficient of your x cube is positive. So it's going up. Now it's going to be touching it here at minus 3, and that's the point there. Minus 3 and 36 also. That's the turning point there. That here, why are we stopping that point? Because it's the x-intercept. That's it there. Minus 3 is an x-intercept, and there are two of them. You can't have more than one, so that's why you're going to have only 1 point. So when you go up, you go to your first intercept, which is also your turning point at that point. And then the next thing is, this is my second intercept. So after leaving there, I come down. Where am I going to? I'm going to be going to your y-intercept. If you look at that place there, y-intercept is minus 27, so it's somewhere there between minus 20 and minus 30. So you go there, and this is the second turning point, which is your 1 and minus 32. 1, and then somewhere there is minus 32, and then you go up to go and cut the last intercept, which is 3, and then you can extend it. So that's the graph. That is how to draw your cubic graphs. That is all about tutorial 1 exercise. Thank you.